Okay. Hey everyone. Let me turn off the music first. Alright. Hey everyone, and welcome back to CS196. So I've made a couple audio changes. Hopefully it sounds clearer than before. But back to the lecture. We are doing Rust today. So we finished Python. We're not going to look at that anymore. And now we're going to move on to Rust. Rust is a really powerful modern language that's being used more and more by big tech companies because it's very, very powerful. So let's go over what is Rust. Alright, so I compiled a bunch of images of Rust, but unfortunately, that's not what we're covering today. We're talking about Rust, the programming language. So what is Rust? Well, Rust is a multi-paradigm system programming language. Alright, so that's a mouthful. Let's break this down. Programming paradigms, or the word paradigm, essentially categorizes programming languages based on their features. A multi-paradigm language is a language that supports several programming paradigms and don't restrict the programmer to a single paradigm. So for example, you're all very familiar with object-oriented programming. You're doing that in CS125 and Java, but Rust can do that, and it can also do functional programming like Haskell and other things. It's very powerful because it's very flexible like that. It's a systems programming language, meaning that it's a language used for systems programming. Pretty obvious. Systems programming used for system software, and system software provides a platform for other software. So it's not something like an app that you'd use, but it's the lower level stuff that an app would run on. Systems programming languages are designed to provide easy access to underlying hardware, and they're optimized for performance. The biggest thing with systems programming is we want it to be as fast as possible and as memory efficient as possible. A big thing about Rust that makes it very popular is that it focuses on safety. So what do we mean by safety? Well, firstly, Rust can be used both safely and unsafely, but we don't have to worry about the unsafe Rust at the moment. We're just going to cover safe Rust, which is the true Rust. Taken directly with the documentation, this is what they define as the true Rust programming language. Safe Rust will still allow you to write high-performance applications without needing to worry about memory safety or type safety, which we'll talk about soon. And a big reason this is important is for concurrency. So if you are familiar with concurrency, it's essentially allowing your code or your code structure to break up into multiple different threads which can do multiple things at the same time. And obviously this is really powerful because you can make your code much faster, but at the same time, you're also going to have a bunch of logical errors that make it a lot harder for you to run this code properly. A big reason that Rust is popular is because it helps you bypass all these logical errors by making it safe, which we'll talk about later on. Syntactically, Rust is similar to C++, but is safer while maintaining high performance. And it's been voted the most loved programming language on the Stack Overflow Developer Survey since 2016. So, is Rust used anywhere? Well, yeah, it's used in multiple places. Several parts of the core file system in Dropbox are written in Rust. Yelp developed a framework for real-time A/B testing in Rust, which is used across Yelp. Mozilla's parallel web processor engine Servo is also written in Rust. Alright, so the basics. So if anybody wants to learn Rust, you have to read the documentation. I know we say this all the time, but the Rust documentation is actually really, really good. It's called the Rust textbook, and it's a great way of learning because it's very dynamic in the way things are taught. So the Rust documentation is very, very useful in learning the language and debugging, and you can run code snippets from the documentation itself. The compiler is another very useful tool that provides helpful error messages. Alright, so your first program, let's get right into it. So setup files and other stuff. So you can find the Rust installation for Mac and Windows and Linux in the documentation here. It's relatively straightforward to set up. And while I'm going to cover how to run stuff locally and how to use Cargo, which is Rust project manager, we'll be using the Rust Playground, which is an online interface to the Rust compiler, for most examples after this. So all the code snippets you see, there'll be links that will take you to the Rust Playground to run them yourselves. So let's start us off. Rust files end with .rs, so Rust. To compile a Rust file, you run rustc and then your file name in the command line. This generates an executable file, and then you can run the executable file. Obviously, this is kind of tedious, so we'll talk about Cargo in just a second. So let's make our first program. So hello world, as we always know, is our first program. So a very quick recap is what a function is. A function is a named chunk of code that does a specific job. The main function is unique because it always runs first. So main should be in bold there, but the main function always runs first. It's common amongst many languages. So the way we define a function in Rust is that we have this keyword fn, which is short for function, and the function name. The parentheses are where we place parameters, and as you can see, we have none at the moment because our main doesn't need any for our first program. And the function is surrounded by curly braces, similar to C++ or like Java. So our first program. So we're going to make hello world. So the way we do that is we use this command println with an exclamation mark. So println is what println stands for. The exclamation mark indicates that we're using a Rust macro. And the function takes the argument, which we're going to print out. A regular function call would not use the exclamation mark. It's only because this is like a built-in Rust macro. And you can run that yourself if you want. But let's do this ourselves over here. So let's open up iterm, go into our desktop, and let's make this file. Let's make this bigger first. So just like we saw in our example there, we're going to make a main function, and we're just going to print hello world. And remember, we put a semicolon at the end of our code, our line of code. So our main, defined by fn for function, main, and then print line. So what we can do now is we can run rustc hello.rs. It'll compile, and notice that we now have this executable here. This obviously wasn't there before. So to run that, we just do /, and then whatever the executable is called, hello world. Super easy. But as you know, we're programmers and we're very lazy, and this is kind of tedious. So how can we make this even easier for ourselves and to make it easier to run big projects? Well, first, let's talk about this first. So we pass the string hello world into the macro as an argument. We end the line with a semicolon. And also one small thing, which isn't really important, but pretty good when you're writing other Rust projects, is that Rust doesn't use a tab. It uses 4 spaces. Now, I know it might seem almost identical, but just as a good style guide, use 4 spaces if you're writing like a typical Rust program. All right, now we're going to go into Cargo. So Cargo is Rust's build system and package manager. And it can do a lot of things like build your code, download libraries that your program is using, and build libraries. So this sounds great. How do I get it? So Cargo should be installed with Rust by default if you follow the installation in the documentation. Really, really important. Read the documentation. To check if you have Cargo, you can just write cargo -- version in your terminal. And if you see a version number, you have Cargo. If you get an error message, then you don't have Cargo. So to make a project using Cargo, you just write cargo new followed by the project name. And Cargo creates a directory with a folder called src, so source code, with a file main.rs inside. The main.rs is what's going to run all the code. So even if you have other files, main.rs will be the first file to be run, and its main function will be the first thing run, and it can call other things after that. It also creates a file called cargo.toml, and this file has information on the project details. And Cargo initializes a Git repository and a Git ignore file. So when you run cargo new, it creates a hello world file exactly like this. And that'll be in your src main.rs. To run this, we want to either use cargo build and cargo run, or just cargo run. Cargo build will basically compile our code. This creates a target directory with a debug directory inside it, and the debug directory has our executable. And to run that, we can just do this long command here to run the executable manually, but that's tedious. We can just do cargo run instead, and that'll run the executable in one line. Cargo also creates a file called cargo.lock, which keeps track of libraries in the textbook. And in the textbook, they're referred to as dependencies. You don't need to worry about this, as Cargo automatically updates all of this. And this is a lot of information. We will cover all this in our demo. Cargo also has a command called cargo check, which will check if your code can compile, but it won't create an executable. And the reason we want to do this is because let's say we just wrote some new code. We don't want to test it just yet. We just want to see whether it'll compile. Is it syntactically correct? We can just do cargo check to quickly check if it's correct, instead of using build, because for big projects, building takes a lot of time. Cargo check is a really fast way to do this. Finally, let's say you've coded for months and months and you've made your Rust project. You can build it for release. So you do cargo build release, and that'll build your code for release. The compiler will provide extra optimizations in the target/release folder instead of target/debug. And this executable will be the exact same code, just faster. So let's first do this. Oh no. All right. Okay. So let's go cargo, hello world, like so. Oh, cargo new, sorry. All right, so notice we have this new folder here called hello world. Let's open it up. Notice we have the TOML file, which keeps all the information about the project. Then we have our src file here. So let's open this up. And notice that it's just hello world. Exactly what we were before, but it automatically did it for us. Now let's first check if we can compile it. So cargo check. Oh, sorry, let's cd into that hello world folder first. Cargo check. Yep, no issues there. Cargo build. And then finally, cargo run. And it worked. But also, we don't have to do cargo build all the time. If we know we're going to run the code, so let's say hello 196, we don't have to run cargo build. We can just run cargo run instead, which will do the build step and then also the run step in one line. Hello 196. Cool, so now we've been introduced to cargo. This is how you can run Rust programs locally. So let's get into actual Rust rules. So first thing, which is very important and probably a little weird for most of you, is variables and mutability. So by default, variables are immutable in Rust. So immutable means that once a variable has been assigned a value, you cannot change this value. The reason this is done is for safety and for safe concurrency. A big issue in concurrency is if you have two threads reading the same data, if they both change it at the same time, we're not sure what that variable could be. By having our variables be immutable, it makes it a lot safer to do concurrency. So here's an example of this. We use the keyword let to declare a variable. So you guys want to guess what this code does? We're saying let change me equals 5, and we're going to print the variable has a value change me. So notice this here, this is how we format our print statement. Whatever is in place of the curly brackets will be replaced by this variable. So any guesses what this does? I'm going to assume you guys are guessing in your head, but I'm going to run this over here. So this is the playground now. So notice this link took me to this website here. This is just the playground where you can run your own code snippets. So just print this because the variable has value 5. Super easy. But now we want to see what happens if we try and change this. So what would this code do? So notice we define our first variable to equal 5. We print this, and then we say it's now 20. What would happen if we ran this? Oof, we got a big old error message here. Let's break this error message down because the compiler in Rust is really, really smart and actually can fix most of your errors for you. All right, so this is the error message we got. This is from my terminal, not from the playground. Notice what our error is. Cannot assign twice to immutable variable change me. So this is the exact line that the error is happening on. But notice that it also tells us what we can do to fix it. Make this binding mutable by changing the code here. All right, this leads us on to our next bit of information. We can actually create mutable keywords, mutable variables as well. And we can do that using the mute keyword. So what this does is indicates to other programmers that this variable's value will change in the program. So we only want to use mute if we know for sure that we're going to change this value. Otherwise, we keep it immutable. So what would this code do? I'm not even going to run it because obviously what it's going to do is print this and then print this line. Actually, we'll run it just so as a sanity check. Cool, no errors, and it printed both of these things. So the key takeaway here is that variables in Rust are immutable by default, but we can still have mutable variables as long as we explicitly define it. Also notice that we don't have to define the type of our variable. We can if we want to, but we don't have to because Rust automatically figures out the type. All right, before we move on, I'm just going to check if we have any questions in the chat. Do executables get replaced or are new ones created? That's a really good question. They get replaced. So those get updated or deleted and then replaced with a new one. So why not just make everything mutable, someone asks. So that goes back to the idea of concurrency. The issue with concurrency is you have one piece of data, let's say a variable called 5, and we have multiple threads all running bits of code. If they all try to change 5 at the same time, for example, we don't know what the actual value of 5 could be. It could be what thread 1 did, it could be what thread 2 did, but we don't know for sure. By making it immutable, doing concurrency is a lot easier. There are ways to get around this, which we'll talk about later when we actually get into concurrency. Alright, shadowing. So in Rust, you can declare a variable the same name as a previous variable. We say the new variable shadows the original variable. So what you might have seen in languages like Python or like Java or C++, if you declare a variable like int x equals 5 and then you say int x equals 4, it'll crash because you're redefining the same variable. Rust doesn't care about that. It lets you do that because the code is essentially saying here that we want to change this value. It's okay that we're changing this value, but the new value is still immutable. This variable shouldn't be changed all the time, but when we do change it, we know exactly where it's happening and why it's being changed, and we don't want it to be changed after that. This is known as shadowing. So looking at this code here, we have let var equals 10. We're going to print out 10. We're going to increment it by 1. And then we're going to times it by 2 and divide it by 4, which will give us this output here. So a couple things to note. Shadowing is different from using mute because we're indicating that we want to make a few transformations to a variable, but still keep it immutable. And I know this seems a little weird because we're changing it but still keeping it immutable, but the reason we want to do this is because sometimes we do want to update the values of our variable, but we don't want it to be constantly changing, and we want programmers to understand when they're looking at my code that we did change the value, but it's not an immutable mutable variable. So we're essentially declaring a new variable so we can change the type. We can say it's initially a number, an integer, or we could say it's a character now, or a tuple, or an array. We can change the type as we're doing shadowing. All right, any quick questions before we jump into the Kahoot? There's a question here, does Rust care about data types? Yes, it does, and we'll talk about that right after this. When you're defining a variable, you don't have to automatically declare the type because Rust will figure it out on its own. The compiler is very smart like that. All right, no more questions, so we're going to jump right into the Kahoot. Here is the code. Let me turn on the music too, because it's like a new Halloween theme music, which is pretty cool. I'm also just going to quickly change something over here. I stole this idea from Sammy. This way you can still see the questions. Alright, when would you use mute versus let var equals something else? So that really depends on the code you're writing. If you're creating a variable that's going to constantly change, then you want to use mutable. But if you're only making a few changes to the variable, which you want people to be aware of but still have an immutable variable, then you'd use let var, you'd use shadowing instead. Alright, I'm going to give you guys like another 30 seconds because we have a lot of stuff to cover today. Alright, we're just going to get right ahead and get started. Alright, question 1. What should I check if I have questions about Rust? I really hope everybody gets this correct. I don't want any jokers right now. I really hope everybody gets this correct. Alright, awesome. Everybody got it correct. Yes, check the documentation. The documentation is really, really good for Rust, and it's really easy to navigate. So please go there if you have questions or Stack Overflow or something like that. But first, the documentation. What command will check if code will compile and create an executable, but not run the code? All right. Yep. So there's definitely a discrepancy between cargo build and cargo check. The difference between cargo check and cargo build is that cargo check doesn't create an executable, whereas cargo build will create an executable. It's building the executable. Cargo new creates a new project, and cargo run will do all three steps. It'll check, execute, and also run. Good job. True or false, an immutable variable's value can be changed. Alright, so a little bit of a split, but most of you guys got it correct. If a variable is immutable, it can't be changed. You can do shadowing to change what the variable is, but that value can't be changed if it's immutable by default. Alright, last one for this run we're doing. How can we define a mutable variable? So someone asked, what about shadowing for the previous question? Well, yes, you can still do shadowing, but it's still an immutable variable. You're changing the variable itself, like you're redefining it, but you're still redefining it to another immutable variable. All right, most of you guys got this correct. It's let mute whatever the variable name equals something. Cool, we will hop back to this in a second. All right, data types. So people are asking about this, so let's get right into it. All values in Rust are a specific data type. This allows the language to know how much space to allocate and how to work with the data. You'll learn about this in 233, but different data types need different amounts of space. You don't need to specify the type when declaring a variable, as the compiler is smart and can infer what data type a variable is. So we have scalar types. Scalar types represent a single value, and Rust has 4 primary scalar types, which are integers, floating point numbers, booleans, and characters. So integers are whole numbers, so have no decimal part. And we can use signed, positive and negative, and unsigned, positive only integers. So this diagram can also be found in the documentation, but these are the different types we have for signed and unsigned. So a signed 8-bit number is I8, an unsigned 8-bit number is U8, a signed 128-bit is I128, unsigned is U128, for example. Oops, yeah. So the number following the letter is the number of bits we use to represent the number. So if we have I with the number n, it means we can represent numbers from negative 2 to the n minus 1 to 2n minus 1 minus 1. The reason for that is it's the way the bits are allocated on the lower level. You'll cover all this in 233 and 241. And similarly for un, we can represent numbers from 0 to 2 to the power of n minus 1, inclusive. So this is the range that we have here for I8 and for U8. If we have arch, so if you notice we had something called arch before, it'll just pick something based on your size. So if you have a 32-bit machine, it'll use 32 bits. It'll use 32 bits. If you have a 64-bit machine, it'll use 64 bits, etc., etc. So we also have floating points, and floating point numbers are numbers with a decimal part. And Rust has F32, which uses 32 bits, F64, which has 64 bits. And F64 is the default if you don't specify the type, because it allows for higher precision with similar speed as F32 on modern computers. So the issue with floating point numbers is sometimes you will have numbers that you can't represent in binary very well, so you do the best you can with as many bits as possible, so the more bits you have, the more accurate that number will be. And the numerical operations are similar to most other languages, plus, minus, multiplication, division, and then modulus, so that's the remainder after division. We also have Boolean types, and Booleans are specified in Rust using the bool keyword. And Booleans can be either true or false, and this is in lowercase. And scalar types can also be a character, can hold one Unicode scalar value. So we use single quotes to represent a single character and double quotes for a string, similar to like C++. Since Rust uses Unicode and not just ASCII, you can hold way more than just ASCII characters like ABCD or numbers. You can hold accented characters like Chinese characters, Korean characters, even emojis, and more. There's a much wider range of characters that you can use in your code. Do you need them? Maybe not, but it's cool to have. We also have compound types. And we have two main compound types. So we have tuples and we have arrays. So tuples are a compound type which can hold several values in a single variable, similar to Python. And we can create a tuple using a comma-separated list in parentheses, also similar to Python. Tuples have a fixed length, again, also similar to Python. So take a look at this code over here. This is how we can declare a tuple. Notice that we don't have to have the same type. See, we have character here, an integer, and then also a floating point number. We also have something called destructuring, where we put the values in the tuple into three different variables. So we have these three new variables, char_var, int_var, and float_var, and we're assigning them to these three values in order, respectively. So now, if we were to run this code, we'd see that we were just able to print out all of these values in the tuple, but we've passed them on to these variables over here. Destructuring is really useful when you want to break up a tuple to do some computation on it. So yep, just as you saw before, and you can run that yourself on the playground. We can also get the value by index. So for example, let's say we only want to print the first value in a tuple. Instead of using square brackets like we normally do, we put a dot followed by the index. So this would print the first value, because we started 0. This would print the second value, and then the third value. We do dot followed by the index. We also have arrays. And arrays are a little different because they are fixed length, which is different from other programming languages, and they can only hold values with the same data type. And we can create an array using a comma-separated list in square brackets. And we'll cover vectors in later lectures, which can grow and shrink in size, but for right now you don't need to know about it, and we will go on to it probably in Rust Lecture 3. So we can declare an array in three different ways. So firstly, we can just create an array and just specify the values like this, just hard code the values. We can also specify a type and a size beforehand. So for example, we want array2 to be of type unsigned 32-bit with length 5, and then put 5 things here. But we can also do it similar to how we did list comprehensions, where we can just specify the value that we want, and then how many times we want to see it. So this array would have 5 cowboy emojis, for example. All right, so I'm going to talk about this code real quick because it's exactly what we saw before, but notice when I'm printing it, I'm not just using our square brackets, also like a colon question mark. That's basically how Rust is error handling. It's kind of really cool actually how it does error handling, and we will talk about that later on. But for printing an array, you just have to do this instead of just your regular old curly brackets. So when we run this, as expected, we have all these arrays printed out. The only one that's interesting is array 3, because notice that we don't just have one cowboy, we have five cowboys, one after the other like that. And we can access a specific index by doing the array name followed by square brackets in the index that we want. And so this is something you're used to. You've seen this in Java, you've seen this in Python. You just put a square bracket and then the index. Something to note though is your index is out of bounds, you will receive an error, and the code will compile, but it'll exit with an error. So this would just crash on us. So notice when we run this, boom, it just crashes. That's expected. A lot of languages do that too. You can't access data that you don't have. Also notice that the compiler here also try to optimize our code for us by saying we have unused variables. So often when you have things that you aren't using, Rust will say, hey, you're not using this, let's remove it to try and make our code a little faster, because systems programming is meant to be very, very fast. And notice that it tells us that the length is 5, but the index is 200. The compiler is really smart and will have really, really good error messages, so it makes debugging very easy. All right, now let's move on to control flow, so the conditional. So we use conditionals to choose what code to run based on the current values. We just have a question come in. How is the second declaration different from the first? Oh, sure. So someone asked, well, how is this different from this? Well, here it is, they're the same. But here, notice that we specify the type and the length. This doesn't change how the code runs. It's just so for other programmers, when they look at your code, they understand exactly what it's meant to be holding. Good question. So control flow, conditional. So conditionals are just if statements. It lets you make decisions in your code based on the current state of variables. The way we do control flows or conditionals is very similar to how we do them in Java or C++. You have if, some statement, else, something else. If you want to have multiple statements, you can do if, else if, else if, else if, etc., etc. So conditions don't need parentheses around them. So unlike Java or C++, you don't need to put parentheses around the statement. And the statements don't need semicolons at the end. So let's take a look at this snippet here. We're saying let x equals 5. If x is greater than 10, print this. If x is less than 10 and greater than equal to 5, then we print this. Otherwise, we just print the number as less than 5. So notice here that our code doesn't need to have parentheses around our statements. Also, this should be greater than or equal to. Sorry about that. So notice that we don't need to put parentheses around our statements. We can if we want to, but it just looks cleaner if we don't. And it's very, very similar to how we do if statements in other languages like C++ or Java. As expected, when we run this, it'll print the second statement because 5 is obviously greater than or equal to 5 and less than 10. Easy stuff. So we use conditionals to choose what code to run based on the current values. And you can assign if statement to a variable too. So let's say we want this variable to be the Boolean of some statement, like let var equal 5 equals 10. It would say var is false. So we can assign this to a variable too. Now we want to talk about loops. So we have 3 different kinds of loops in Rust. We have the regular loop, which is just this. We have a for loop and a while loop. So let's talk about the loop first. A loop will just repeatedly run a section of code, and you can assign this loop to a variable as well. We can use the keyword break to leave the loop and return the value to a variable. So this is weird because we have never seen this in any other language, so let's try to break it down a bit. So firstly, we can just use loop to run some code until a condition is met. So in this case, if we say let mutable x equal 10, we loop, and as long as x is greater than 5, greater than or equal to 5, we keep running here. If x is less than 5, we break. Otherwise, we remove 2 from x. So obviously, if we're moving 2 from 10 until it's less than 5, we'll break once we have 4. And as you can see, if we print this output here, we get 4. The loop just runs until you break. But what's different about loops, or what's unexpected, is that you can also assign this to a variable. So let's say we have this mutable variable y, and we call it 0. So we can loop up until y is greater than or equal to 10. This should be y, not x. If y is greater than or equal to 10, we break, and then we also multiply this value by 10. Otherwise, we just increment it by 1. So what this is going to do is from 0, it's going to keep adding 1 to y, or we'll call it x here because it says x. Once x is greater than or equal to 10, we break out of the loop, and while we're breaking out of the loop, we also multiply x by 10. And this will give us an output of 100. So does that make sense? Are there any questions about how this works? Because obviously this is a little different to what we see in other languages. All right, I think you guys get the gist of it. Nope, someone said, wait, what? Okay. If you have a question about it, drop in the chat and we can always jump back to it. Oh, that was just a syntactical error. This should just be x, not y. Yeah, that's just a typo there. This should be x, not y. Why are we printing the loop instead of the variable? Well, so what this is doing is this is returning the variable that we break with. So think of this like a return. Think of break as like a return statement. We're returning this value here, which is x times 10. Therefore, we're going to, once x is greater than or equal to 10, we return, or we break, and we return the value x times 10, and we pass that to the variable var. So someone asks, why do you want to assign the loop to a variable? Well, it's because the loop is almost like a function in itself. Once we break, we can return this value to whatever variable we assigned it to. So var would simply be x times 10 here. Yes, so exactly. Someone said, so is x 10 and var 100? Yes, x is 10, but we say var is x times 10, which is obviously 100. All right, so moving on. We also have while loops. So while loop will just repeatedly run a section of code while the condition is true. So while this condition is true, run code. It's very, very similar to what we've seen before in Python or Java or even C++. So what do you think this code snippet would do? Let x equals 20, while x modulus 7 does not equal 0, we print what x is, and then we decrement it. What do you guys think this is going to do? Just going to take a look in the chat if there's any guesses. All right, no guesses. Well, if you think it's going to keep printing from 20 to 14, you'd be wrong. It's going to crash. And notice it's because our assignment of x isn't mutable. So this is a very common bug. It's when you try to make an immutable variable have its value be changed. You can't do that. We fix this by saying let mutable x equal 20. And now we keep printing it and decrementing it till we hit x equals 14, because if it's 14, that's a multiple of 7, and we break out of this while loop. This statement is no longer true, so we break out, and this would be our standard output. All right, so while loops are pretty basic. You can have as long as short of a statement you want here. They work exactly as you'd expect in Java or C++. Now we have for loops. So for loops allow you to iterate over a collection of values. And this is pretty generalized, and you can do more with them, but this is a pretty good way to start thinking about them. The loop will run the chunk of code for the length of the collection that we have, or whatever range that we have. So we're going to cover the indexed for loop and also the for each loop. So this is what you're probably used to in like C++ or like Java. For I equals 0, while I is less than 10, iterate, do something I times. And this is also known as the C-style for loop. And this is what you do in Rust. In Rust, we say for I in this range, so 0 to 10, do something I times. And the top number is exclusive. We don't include that. And this is your reference for what it would look like in Java. These are exactly the same, except this is Rust, this is Java. And we'll show an example for this in a second. So we also have for each loops. So if you remember in Python, we had for each loops where you'd say for variable in array, print the variable. And we just print every variable in the element. We can do something similar in Rust. So let's say we know we want to iterate over everything in this array or tuple. What we can do is say for variable in collection.iter, so dot like iterative or iterable, we want to run code for each element. And this loop will run the chunk of code for that length of the collection. So here are two loops. So we have this first array called array. This is the indexed for loop in our C style. So for x in 0 to 5, we print all those values. So we go 0, 1, 2, 3, 4. We know that we don't include 5, so we leave the loop. We can also do for each. So for variable in array.iter, print the variable. So we can run this in our playground, like so. And notice that it prints ABCDE for this first loop, and also prints ABCDE for the second loop here. Does iter return iterator? Someone asked. Yes, it does. All right. So any question about for loops? Because they are mostly, or while loops, or the regular loop. All right. So now we have functions again. We're going to talk about how we normally return with functions and how we're going to do it in Rust. So this is what you're probably used to. In Java or C++, you have your function type here, the function name, your parameters, and then something, and it returns. If you're not returning anything, you have void, and then it returns nothing. And these are also called C-style. Also, shout out to Sammy for these slides. You did a great job with them. So this is what you're going to do in Rust. So in Rust, we first don't put our return type at the start here. So notice we don't specify our return type at the start of the declaration. Instead, we specify the return type at the end of the function declaration here. So we know that this function is going to return an i32, an assigned integer with 32 bits. Notice to return, we don't need to explicitly use the keyword return. So unlike in the C style where we had to say return first number plus second number, here we can just say first number plus second number. So the compiler is smart and it knows if you're just going to say x instead of saying return x, it'll understand that you're trying to return. And also, one last thing to point out that's different is the way we define our input parameters is we put the variable name, colon, and then the type. So we know that this is first number variable is an i32, second number is also an i32. But you can also do it in a more C-style manner, which is exactly the same, except we can also explicitly use the return keyword as well, like so. And if we have a function that returns nothing, we just do fn do nothing, so function do nothing, and we don't put a return type. We don't need to specify void or something like that. It figures out that if you have nothing at the end, no return type specified, you're not going to return anything. Any questions about any of that stuff? About the return types or about declaring functions with return types? All right. Before we move on to the Kahoot, I do want to point out one thing with our loop. So loop is the one confusing thing from all the control flow stuff. Notice that when we're trying to assign loop to a variable, we have to put a semicolon at the end. If we're doing a regular loop, we don't need to, if we're just looping for the sake of looping, we don't have to put a semicolon at the end. But if we're assigning it to a variable, we do put a semicolon at the end there. All right. And the last thing I'm going to talk about, which is very useful, is comments. So comments are lines of text in your code that the compiler will ignore. And you should use comments to explain what your code is doing. Pretty basic stuff. Comments in Rust are at the // similar to C++. So this is a comment, the compiler can't see me. All right, so now let's jump right into our Kahoot. I'm going to give everyone a second just to catch up / hop back on. And yeah, as I mentioned in the chat, if you want to return, you leave the return and you don't put a semicolon at the end. All right. Question 5. What will this code print? Oh. Give me a quick second, guys. Sorry about that. So we have this x here, and we have a bunch of different cases. How good is your mental math, essentially? I think I'm just going to jump ahead in the interest of time. Yeah. All right, so it's the second one. Just because we take 527, x mod 100 is 5, which is less than 50, or sorry, 27. X mod 5 is 27, which is less than 50, but x mod 100 is greater than 30. Therefore, since x mod 100 is less than 30, we print is it the second. Because x mod 100 is 27 here. All right. Next question. These are also more code heavy. What will the value of var be here? This one's a little tricky, but it's using what we learned about the loop command. Notice that it's a greater than sign here, not greater than or equal to. Alright, I think I'm gonna jump ahead because I don't want to talk about this answer. Alright, most of you guys got it correct. The answer is 60. The reason for that is we are gonna loop through this until our counter is greater than 25. Once it's greater than 25, we break from here and we set this value to var. So if it starts at 0 and we're adding 5 each time, we'll go 5, 10, 15, 20, 25. And once we're at 30, that's when our counter is greater than 25. We break and we return counter times 2, which is 30 times 2, which is 60. And that's why our correct answer is 60. So good job, you guys. Most of you got that correct. Finally, our last question. What is the return type of the below function? Someone guessed that before the question even came up. It's really impressive. So we did talk about the data types at the start. Alright, sorry about the shorter time there, but yep, most of you got it correct. This is our function called sum function, takes no parameters, and it's returning an unsigned 128 or U128. Alright, so good job, guys. Here is the podium just for fun. Extra credit for Kahoot. I think probably not, just because of latency and stuff. It's unfair. Alright, so good job, you guys. Top 5. Cool. Alright, so with that, are there any more questions about Rust or about the next couple of weeks of the class? If you have anything, drop them in the chat or in the Twitch chat, and I will get to them. Yes, so that's a really good point. The Rust homework will be out tomorrow morning. With the Rust homework, the parallel and autograder is a little